I'm just gonna uh so I just stopped it and start again. And the standard unit vectors, I think we talk about this, right? So remember that the I and j, when we study the vectors, we talk about this. Um, so that we have this okay, I is here. Okay, so what does it want to say? Or called the standard unit vectors. Okay, so vector components. So V may be decomposed into two perpendicular vector components. So yeah, it's almost like, yeah, so it's using the vector sum. All right. Yeah, so have to like the side of our triangle, and then the summation of these two vectors is gonna be this direction. Sure. All right. So, and then the link between scalar components and the vector components. Yeah, of course. So it just give this vector v as a direction I, and also the magnitude give this vertical, like a direction j, magnitude v, vy. I think this is fine. Yeah, I trust you guys. And also yeah, so this is just a way of writing a vector using right, so remember the last time we talked about it, right? So you can write a vector as the linear sum of two other functions, of two other vectors, right? Right? So it's just our our decomposed vector set is I and j, right? Right? And also, okay, sure. So displacement of two vector from B to A. Yeah, the last time I think we also talked about it. So the x and y coordinate would just be, yeah, the x of b minus x of a, yb minus y of a, and then we project it onto this two I and j directions, right? So yeah, so let's see. Find the magnitude of this. Find magnitude. Magnitude would just be our r radius, right? So you can say radius r or v. The magnitude will just be square root of vs squared plus vy squared. I think you can write it down, and 4 squared plus -3 squared, and then and convert the vector into the form. I think you guys can write it, right? And then convert to this. I'm sure you know. So this 4i minus 6j, right? Find the vector components. Yeah, just write it in this form, okay? So yeah, it's like another, like writing this as linear sum of I and j, and I'm sure you know O is just origin, right? So we say that a point also defines a vector, like just emanating from the origin, right? So it's just gonna be, and then we write it as the sum of I and j, so -2i plus -3j, something like that, right? Okay, so I'm gonna skip this and see. All right, so 3D coordinates, and consider 3D coordinate system and 3D vectors. Yeah, I guess this the only thing a little bit harder about this is that in 3D the angle is a little bit tricky to visual, but yeah, but it's again like it's an angle, and then with respect to each of the coordinates, right? And yeah, and then the x, y, z, you can take the shadow on its x and y on each of these coordinates. I think it's not much to say. Yeah, and also it's the same with 2D. The same with 2D. So yeah, so for example, if I were to single out, only pick v and x right here, if I only pick v and x, and then I look at it from the right, and then this is v and x, and then this their angle gonna be alpha, and here it's a v and y is angle gonna be beta, and also v and z, right? So v and z, right? Yeah, so yeah, so it's the same thing. So just as our let's see, yeah, I guess the only thing different is that um yeah, I guess in 3D the only thing different is that it's using cosine. It seems like it's using cosine everywhere. Yeah, I mean, it also depends on how you define this alpha, beta, theta, right? So this alpha, beta, theta respectively is the angle between the vector and the positive direction of the coordinates, right? So yeah, so because this this help us define this relation, right? Like v times cosine alpha, v times cosine beta. Like we didn't use sine here because the angle that we define 3 angles. So the angle that we define is different than the 2D, right? So in 2D we only define one angle like theta here. Alright, so alright. So yeah, exactly. The angle is a vector, and then the coordinates. The vector v and coordinates y. We're just gonna picture it in this direction, v and y, right? Okay. Alright, so and then so if you project this vector to xyz coordinates, it's all going to be using cosine alpha, cosine beta, cosine theta. It's all cosine. And as we know, their coordinates on xyz, and then the length is the same with higher dimension. Is square root of x squared plus y squared plus z squared. Okay. And then yeah, exactly as we define here, so we can calculate cosine alpha, beta, gamma, right? And then sum square of them is equal to 1. So yeah, it's just it's a good conclusion to know. And then okay, so the magnitude the same as here. So just remember this here, this picture. I think it should be good. And then we are just gonna apply this, right? And the magnitude of the vector and directions. Well, I think that so OX, OY, OZ is just positive direction of XYZ coordinates, right? Yeah. So I think definitely you are able to write this out yourself. And then the only thing that I'm doing is maybe just to like give you a company of writing out these like a little bit tedious relations, right? But exactly applying these. Okay. So it's going to be vx, vy, and you should try to write it yourself because I'm really just applying this formula and you can't just remember everything, right? Because before exam you can't remember everything, so try to write these yourself. using the formula that we have just on the right, right? So what is Vx? You should write it down, right? Just have a radius and then the cosine of, we need to double check this. This definition of alpha, beta, gamma is exactly the same with the definition here, right? Because sometimes I think if the question is mean, like it can give you different definitions of alpha, beta, and gamma, right? Yeah, it can give you different definitions. But here is the same. Like here, if you see like this notation AOX, is the same with like is a direction angles alpha would be like the angle between the vector and uh uh yeah, it would be the angle between angle between the vectors. Sorry, not here. Should be the angle between the vectors and the positive directions, right? So here's the definition is the same. So yeah, so if you agree with me, you wrote it down already, so it's just gonna be 20, so which is the norm of a and then times cosine alpha and the norm of a times cosine beta, and we just plug in, right? Cosine alpha, this is cosine 60, and then this is a is 20, right? Yeah, and then norm of a and then times cosine uh and then cosine gamma. Okay, yeah, and then you just plug in the length of a and the angles. All right, all right. Okay, so yeah, so I think this is a little bit hard, right? Find the direction of the angles for the vector. Yeah, I think we're just, if you're gonna solve these angles, I think we're just gonna assume the definition here, right? The angles between the vector and the positive directions. Yeah, you can so you can start writing out our definition. It's just starting writing out our definition, right? So this is our Vx is Vs is -2 is our V times cosine alpha, right? Or you can directly say that our cosine alpha is equal to so this is Vx, right? So here and here, you're just gonna remember one of these sets of definitions, right? So then cosine alpha is going to be so you just remember one of these, right? One of these. So just here and I think here and here will be good. So and then our cosine, if you remember this, and then you can just divide norm of v on the other side. So cosine alpha will just be -2 over the norm of v, right? And the norm of v, we know it's just going to be just going to be -2 over the square root of these, right? So the square root of -2 square plus 3 square and then plus -1 square, right? Okay, so and similarly you can write out Vy is going to be 3 and going to be V times cosine beta, and then Vz is, you should write it out yourself, right? Really, -1 is V. Yeah, so I just remember one of these, right? Because I know in the exam I couldn't remember everything. So I'm just gonna pick something that I'm comfortable to remember. If you can directly write out these, no problem, right? So, but I think this is natural to me. And then -1 here, the z coordinates here. -1 is v times cosine gamma, okay? And then if I have this, and then it'll be easier to write out the cosine beta is equal to blah blah. So 3 over v, right? Yeah, so I guess the norm of v, we can just directly after getting this question, you can immediately write out the norm of v is square root of this square plus this square plus this square. So norm of a vector after we get a point, any point like in 2D graph, 3D graph, after we get a point, we can always directly write out the norm of the vector, right? 3 squared and then plus -1 squared. Alright, so this is not bad. Alright, so and then yeah, I trust that you can write out the 3 over v and this and here cosine and then I think if you leave it here, it should be fine, the cosine. But I guess you could also write one more step, like arc. So alpha would just be arc cosine so -2 over this, right? Square root so 4 plus 9 plus 1, you can calculate this, right? So arc something will just be like give you the angle, like the inverse function of a cosine, right? Or inverse arc tangent is inverse function of tangent, right? Just gonna give you the angle such that is equal to a cosine value, right? Yeah, and then you can write out beta is, you can write out gamma, okay? Okay, if you find out the vector, yeah, you can write this out, right? So v is equal to square root 4 plus 9 plus 16, okay? And then 3D standard unit vectors, okay. Yeah, it's exactly like our 2D, I, J, I and J, and just pay attention, it's the standard unit vector, right? Yeah, so I think this is obvious. Just be familiar with this notation I, J, and K. Alright, so vector components, we just write out the shadow on x coordinates, y coordinates, and the z coordinates. And then write the, so this is like the magnitude. So first is the magnitude and then direction. The magnitude, direction. Yeah, so this green is saying it's like a point. If you have a point in space and then we have a vector emit from the origin to this vector, so to this point, and then we have a green vector, right? This green vector, and then we have a shadow on x, y, z coordinates respectively. Alright, so a 3D vector may be written in algebraic form. Yeah, again, like we can write it using, so again, like decompose the vector as a linear combination, linear sum of I, J, K. Alright, so write out a vector as a linear combination of a set of we say coordinates vectors I, J, K, right? And then in front of I, J, K, the scalar Vx, Vj, Vy would just be their, yeah, scalar, like the magnitude on these coordinates. And then you can also just write out in this form, okay? So I think it is obvious. And then position, okay, again, repeat again. And then displacement, sure, if you have 2 points and then 2 points can define a vector, right? Because OA is just the coordinates of A point and then minus the origin, right? So OA is just the coordinates of, let's see, So OA is just the coordinates of x, y, z, and then minus 0, 0, 0, right? Minus origin. And then, of course, then you generalize to more general statement like AB between the vector AB between 2 points A and B. It'll just be this, right? So yeah, so xb minus xa, yb minus ya, and then zb minus the a, right? Yeah, and of course, you can either write it in a Cartesian form, like this form, the coordinates, or you can write out, specify the vector vector directions here, here, and here, right? And then it's scalar. All right, so not bad, not bad. All right, so convert the vector into, yeah. So I mean, provided the IJK definition exists, we can write it out as -3, -4, 2. All right, so okay, there's no other page. And then again, convert this into the form. Yeah, I think you know how to do. Just the vx is 3, -3, and then vy is 4. This is -5. Find the vector components. I think you know. Just this is called the vector components. Okay, this is called the vector components. I think you know. And then the algebraic draw diagram, exactly like I said, like from origin, and then P, I guess P is here. Okay, yeah, I think this is a little bit I don't know, too obvious. Okay, I think we're gonna end this section. And goes to the next one is 6.6, right? So you can download it online. 6.6 operation of this. I think this should be okay.